Hello guys, this is CodeNCode and this is video tutorial for the problem first missing positive taken from Leetcode top 100 like questions. The problem is of course hard and we'll be solving this in linear time with using only constant extra space. So let's see what the problem statement says. So of course you are given an array, unsorted array, and you have to find the first positive integer that you cannot find in the array, that is basically missing from the array. Okay, again we have to find positive. So we will ignore negative and 0. And of course in the problem statement you can see they are emphasizing on the running time. This should be solved in linear time, and also you are only allowed to use only constant extra space. Okay, so this is the problem statement. If you can see, suppose this was the input 3, 4, minus 1 and 1, you can clearly see that the first positive integer that does not exist in this array is actually 2. So that is why we have output 2. Here 1 and 2 exist, 3 does not exist, so the first positive integer that does not exist in the array is 3. Now prerequisite. So there is not any special algorithm that you need to learn to solve this problem, the solution that I'm going to discuss. So you should be only comfortable with any programming language. That's enough. Observation. So now suppose you are given an input of size 4. As you can see, I've presented them as A, B, C and D. That means the content of the array does not matter for the question that I'm going to ask. So the question is, can solution of any input of size 4 be actually 6? Just think about it. Pause the video and think. So the answer is actually no. It is not possible. Why? For answer to be 6, you should already have 1 to 5 all integers present in the input array. But for that, the size of the input should be 5 and we have only 4. So answer cannot be 6 or greater than that, right? So the maximum answer can be is 5, that is n plus 1. So if you have an input of size 4, input array of size 4, the answer can be at max 5. Okay, so this is an important observation. If you have an input of size n, the answer can be at max n plus 1. Important observation, right? This was this observation is kind of easy, but still we'll go through this. Think in reverse order. So in reverse order, you already know the answer of certain input is going to be 7. Okay, what observation can you make about it? What observation can you make about the input? As I already told you, the question is quite easy. So just think about it. Okay, now in the meantime, let me ask you this. Are you a student or a working professional who is looking for a great career in software development? Then you have to think about the aspects like what's trending in the industry and the kind of questions being asked in interviews. What's the thought process behind the architecture of great applications like Google, Amazon, Zomato, Ola and others? Show hosts on Unacademy are working with some of the top companies like Google, Amazon to name a few. They are 7-star coders on CodeChef and industry experts with years of experience. They will walk you through their own experience and interact with the guests like HR and industry leaders of top companies. There will be a lot of content being covered in these shows. In live episode, you will get opportunity to ask tech HRs about top 20 interview questions and industry leaders directly about their recruitment process in startups and MNCs. What's the eligibility and how to apply and how they build such great products. Even get your resume and your college or personal project improved by getting them reviewed by expert SDEs. And not only this, you can participate in mock interviews and learn courses on programming languages, cloud computing, or tech aspects of digital marketing and data analytics. Have you ever thought about how these frontline apps like Zomato, Paytm, Google Pay, Amazon, Flipkart, and Practo were made in the first place? What was the thought process? We have a show to answer all of these questions. In this show, Anuj will discuss the architectural breakdown of popular apps. Learner will get to see how these apps are made and how these apps work. Some of the differentiators that you'll find here but not on YouTube are of course live projects and interactive sessions. Now let's head back to our lecture. So the answer of the observation that I asked you is clearly that it means answer of this is that it means all the numbers from 1 to 6 already exist in the input, right? input might have been something like this or other, doesn't matter, but the important thing is that all the number from 1 to 6 already exist, right? Now, so now the question is, how would you know that all the number from 1 to x exist, right? Because the array is actually not sorted and you have to solve the problem in linear time. So how would you know that all the number from 1 to x exist? If all the number from 1 to x exist, answer will be x plus 1, right? If x plus 1 does not exist, that is what I mean. So how would you know that? Well, reordering is the key. What do I mean by reordering? See, what we will be doing is that we'll be placing or reordering the array in such a way that 1 will be present at position 1, 2 will be present at position 2, and so on, as long as we can, right? And of course here you can see, and after that, if this reordering is done, you can find out what is the solution pretty easily. If if element x does not exist at index x minus 1, that means your solution is x. For example, here you see 7 element 7 does not exist at index 6, right? That means your answer is 7 itself. As simple as that. If you have this reordered array, you can run from 1 to n and see which element is not currently present at its position. Clearly, at position 7 we should have had 7, but we don't have, so 7 will be your answer. Now the question is how you convert your input into this reordered array, right? Let's see that. So we are going to reorder this input, right? And how we'll do that? We'll rearrange any element in the range 1 to n. So we won't care about negative numbers or 0. We'll only, and also if n here 3, 6, 9 elements are there, n is equals to 9. So if the element is like 10 or greater than that, we won't care about them. We will only rearrange the elements, and we'll make sure that these are on their correct position only in this range. Okay, so since this is outside of our range, we won't care about it. So we'll simply our I pointer will move on. Basically we are running a loop from 1 to n. Okay, 0 to n, because we are working with 0 base index system. So we move on from here to here. Now we see that 5 is ranged from 1 to n is 9 clearly. So we will see whether this is on its correct position or not. The correct position for 5 is index 4. So at index 4 we are having 3. So what we will do, we'll simply swap these two. Okay, now swapping is done. We will not move on. We will check whether the current element is again in our range or not. The answer is yes, the current element. After swapping again we'll check. Okay, so again yes, the current element is in our range. So we will again see what is its current position, correct position. So its correct position is index 2, and at index 2 the element is not 3. At index 2 we have 2, right? So we will swap these two again. After swapping, I have 2 here, 3 here. So now I will again check. Okay, this is a while loop. So I'll again check whether the current element is its correct position or not. So current element is 2, its correct position is at index 1. So currently it is at correct position. So we will move on. Now we will again check whether 3 is at its correct position or not. The answer is yes. So we will move on. This is outside our range. We won't do anything. Is 5 at its correct position? The answer is yes. What we will do, as soon as I reach at certain index, I'll keep on swapping element to its correct position until the current element is at its correct position. Okay, so element 5 is clearly at its correct position. So we will move on to 6. Same goes for 6. 1. Is it at its correct position? The answer is no. It should have been at index 0. So we will check whether clearly this is not on its correct position. We will check whether index 0 is having 1 or not. Index 0 is not having 1, right? So we will swap element at index 0 with this. So it will become 1 minus 1. This is minus 1. Now we'll check whether this is in the range. The answer is no. So we can move on. Is 8 at its correct position? The answer is yes. So we will move on. Is 4 at its correct position? So the answer is no. So how we know? We'll go to index 3, this, and we see that this is not 4. So clearly we have to swap these two. So we will swap and now here I have 0, and clearly this is outside a range which we care about, so we will increment our I pointer. This will go outside our range, and that is where we stop. So you can see now the array is actually, or I mean reordered in such a way that you can run a loop from left to right, and see what element does not exist at its place. Starting from 1, you should have 1, then 2, then 3, 4, 5, 6. Next you should have 7. If it is not, then simply break and return 7, right? This you already know how to do, right? So I don't have to explain that. So let me just show you the code here. So let's increase the font size. So again, n is the size of the array. What we are doing, this is the reordering phase, and this is the result finding phase, and returning the result. Okay, so what are we doing here? We are running a loop from 0 to less than n, and this is the first condition, the condition that we are checking only the element in the range 1 to n. That is exactly what we are doing here. And if the position of the current element, I mean, if here the second condition, this is checking whether the element is at its correct position or not. If the element, if the ith element is actually x, then we have to check position x minus 1 in the array, right? To check where, for example, if the element is 5, I'll check index 4, whether at index 4 we have 5 or not. So that is being done here. And if it is not, what we'll do, we'll swap these two elements, okay, ith element and element at position current element minus 1, right? You understand that? We will swap them. After that, we again check. This is a while loop, right? The first thing what happened with us, right? First we swap with 5 and 3, then we check with 2, and so on, right? So this is a while loop, because it is possible that after swapping, the current element that comes at ith position is still not at its correct position, and that's why we have while loop. We will keep doing this until the current position is having the right element. After this reordering, we have the reordered array, and after that you can solve this problem yourself, right? I mean, that is exactly what I'm doing. The first element should be 1, then second element should be 2, and so on, and we'll run a loop till less than n, of course. And if any element is not at its correct position, basically if ith element is not equal to I plus 1, we will simply return I plus 1. Otherwise, we have gone through all of the elements, and none of the elements I mean, basically all of the elements are present from 1 to n, so we have to return n plus 1, right? And that is what is being done here. So yeah, this is the solution of this problem. If you have any problem in your mind that you want editorial for, you can post it down in the comment section. So I'll be providing the link for solution of this problem in the description, so you can use it as a reference. So this was all for this lecture. Thank you guys for watching, and till the next video drops, keep coding. Thank you.